Alright, quick science pit stop, evaporation. It's just a liquid turning into a gas. Take a glass of water at room temperature, around 20°C Celsius. The particles in there are zipping around in random directions. Random meaning unpredictable, some are slow, some are fast. The fast ones carry more energy. At the surface, a few get fast enough to break free and launch into the air as gas. Some get pulled back, the lucky ones escape for good. When those highest energy particles leave, the average energy of what's left drops. Lower average energy means lower temperature. That's why evaporation causes cooling. You felt this. Step out of a pool, and you instantly feel chilly. The water on your skin is evaporating, taking the speediest particles with it. The energy to make that phase change comes from you, your skin's thermal energy, so your skin cools down. Sweat works the same way. A common misconception is that wet skin causes cooling. Not quite. Sweat starts at skin temperature. It's the evaporation that cools, because evaporation lowers the sweat's temperature. Heat flows from your warmer skin into that cooler sweat to keep the process going. But there's a catch. If the air is super humid, sweat can't evaporate well. That's dangerous because you lose your main cooling mechanism. Your body temperature can climb. Humans didn't invent this, we just hacked it. Classic clay water cooler made of porous material. Porous means water can slowly seep through. A little water wicks to the outer surface and evaporates into the air, stealing energy from the water inside and cooling it down. Old school tech. Killer results. Some air coolers do the same trick. Imagine a sponge soaked with water and a fan pushing warm room air through it. The warm air supplies the energy needed to evaporate that water. After evaporation, the air has less thermal energy, so it exits cooler. It's AC by phase change. Not all liquids evaporate equally. That depends on how strongly their particles attract each other. Weaker forces, easier to escape. Stronger forces, harder to escape. Perfumes have relatively weak intermolecular forces. They're designed to evaporate quickly so that you can smell them. Perfume on skin. Water on skin. The perfume will feel colder because it evaporates faster and pulls energy away faster. Liquid soap? Stronger forces. It evaporates way more slowly than water. Same test. Equal volumes, same temperature, and the water will feel colder because it evaporates faster and removes heat faster. So the rule of thumb, faster evaporation equals stronger cooling, as long as the air lets it happen. Dry moving air, evaporation party, humid, still air, not so much. Evaporation is just particles on the move, fast ones escaping, cooling everything they leave behind. Your skin, your drinks, your home, ancient clay coolers. Alright, that's the heat escape playbook. Stay cool.